Hello everyone, welcome to the video lecture series on circuit analysis 1. In the last session, we have seen the one of the basic law, which is Ohm's law, the relation between voltage and current, the relation between power and voltage, current and resistance, and also the representation or the relation between resistance and conductance. What does it mean resistance? What does it mean conductance? How current will be passed through the element when the element is expressed with conductance or when the element is expressed with resistance. And we have seen also the relation between voltage, current, and resistance using Ohm's law. Okay, and we have done we did three examples. Now let's add the remaining two examples. That means the fourth one, which says that an electric light bulb is connected to 150 supply source and produce 100 watt of light. So we are asked to determine the current flowing in the bulb and the resistance of the bulb. Okay, so let's do this solution. Let's do this solution. That means let's draw a simple circuit. Let's draw simple circuit. Okay, let's draw simple circuit. So using this, we can have, let's say this is the source, which is 250 volt. Okay, and let's say this is a lamp or the bulb. So we have given the power consumption for the lamp is 100 watt. So let's say PL, which is 100 watt. Okay. So the first equation, we are asked to calculate the current flowing in the bulb. So I, which is equals to, or IL, which is equals to how much? We know that P, it is given by voltage times current. So for this case, I can be expressed by using P over V. P over, or power divided by voltage will give the current passed through the lamp. Okay, so IL, which is equals to PL over the source voltage. What's PL, which is 100 watt, and what's the source voltage, which is 250 volt. 250 volt. Okay, 250 volt. So you have this, which is 10 over 25 watt over volt, which is, you know that the expression for watt over volt, it is current, which is ampere. So you have 0.4 ampere. Okay, 0.4 ampere. The second one, we are asked to determine the resistance of the lamp. Second one, which is RL, how much? RL is how much? So for this case, we have the source voltage, which is 250 volt, and the current I, which is equals to 0.4 ampere. So we, from Ohm's law, we know that R is given by V over I. So RL, which is equals to 250 volt over 0.4 ampere. 0.4 ampere, which is 625 volt over ampere. You know this expression is omega, so you have 625 ohm. So that's how we can determine the value of the resistance. Of course, the resistance can be determined by using V square over power. Okay, so that's how we can determine the quantity. The third one, which is an electric stove which has 110 ohms of resistance is supplied to a 220 AC voltage. So determine the power of the stove, So for this case, we have given that R of the stove is given by, which is 110 ohm, and the voltage, which is 220 volt AC. So we are asked to determine the power of the stove. Okay, so the first one, which is PS stove, how much? Okay, so P stove, which is given by V square over R. Okay, so the voltage is 220 volt, the whole square. The resistance of the stove is 110 ohm. Okay, so P stove, which is equals to 220 volt times 220 volt over 110 ohm. Okay, 110 ohm. So this will be cancelled too, which is 240, 2 times 220, which is 240 volt times volt over omega. You know that this expression, it is ampere, so 240 volt times ampere, volt ampere, it is watt. Okay, so we have 240 watt. Okay, this is how we can determine the power of the stove. The second one, it is we are asked to determine the energy consumption by the stove. Okay, stove, energy of stove. Okay, or ES. How much? Okay, so based on this, we know that energy which is equals to power times time, because we have given time is 2.5 hour. Okay, we have given. So the energy of stove is given by, the energy of the stove is given by the power is given. The power is already calculated, which is 240 watt times the time is 2.5 hour. Okay, 2.5 hour. So you have the value, which is 1100 watt hour, or which is 1.1 kilowatt hour. So you know that we pay our energy consumption using kilowatt hour. Okay, kilowatt hour. So this is one unit for the energy consumption of the stove. Or we can express the energy consumption of the stove by using joule. That means we know that 1 hour, which has 3,600 second. So this stove, which is equals to 1.1 times kilowatt times 3600 second. Okay, 00 second. So which is watt times second, which is joule. So we can have 1.1 times 3600 kilojoule, because watt second, which is equals to joule. Okay, so using kilowatt hour or kilojoule, we can express the energy consumption of the stove. Okay, so that's all about for Ohm's law. When come to for coming to the Kirchhoff's law, let's consider this very important terms. Okay, nodes, branches, and loops. Okay, so a branch in a circuit represents a single element, such as a voltage source or a resistor. For example, if you consider this circuit, okay, so as you can see here, which is V, this is I, this is R1, this is R2, okay? So we have 4 components for this circuit. We have 4 components for this circuit. So for this component, resistor R1, which represents one branch, the voltage source represents another branch, and the resistor R2 represents another branch, and the current source also represents another branch. So this circuit, this sample circuit consisting of 4 number of branches. So a branch connects to nodes, okay? Connects to node. So it represents a single element, okay? It represents a single element in a circuit. It can be a voltage source, can be a resistor, it can be capacitor, or it can be current source, okay? A node is the point of connection between 2 or more branches, okay? A node is the point of connection between 2 or more branches, okay? So this is the first branch, and this one is the second branch, and this is the third branch, okay? Third branch, which is third branch, and this one is fourth branch, okay? So it says that the point of connection between 2 or more branches, for example, branch 1 and branch 2 connected at this point. So this is a node for branch 1 and branch 2, okay? And this is a node for branch 1, 2, and 4. I mean branch 1, 3, and 4, okay? And node for branch, okay? Branch 1, 3, and 4, okay? This is a node for branch 1 and 2, and this is another node. This is node for connection of branch 2, branch 3, and branch 4, okay? Branch 4. So that's how we can define a node in a circuit. A loop is any closed path in a circuit. For example, we can consider this. Plus minus. Okay. So we can say that this is A, B, C, D, E, F. Okay. So for this circuit, this is V, R1, R2, R3, and R4. Okay. For this circuit, loop A, B, C, D, E, F, A. This is one loop. Okay. And A, B, E, F, A. It is another loop. And the other one is B, C, D, E, B. This is another loop. So this circuit has consisting of 3 closed loops. Okay, 3 closed loops. And it has 2 independent loops. That means this loop and this one, they are independent loops. Okay, totally it has 3 closed loops. When we come to a network with B branches, okay, B branches, and nodes, and L independent loops, like this loop and this loop. Okay, we can have the relation between branch, which is given by, this is a branch of a circuit, which is given by loop. This is a loop of a circuit. This is node of a circuit minus 1. So if you have the loop of the circuit and the node of the circuit, so you can determine the number of branches for a given circuit. Okay. So these terms are very important. To further proceed for circuit analysis, especially when we are dealing with node analysis, mesh analysis, okay? When we are dealing with Kirchhoff's law. That means Kirchhoff's voltage law. We are going to apply voltage. A loop. When we are applying Kirchhoff's current law, we are going to consider a node. Okay, node should be considered for Kirchhoff's current law. Loop should be considered for Kirchhoff's voltage law. So these terms are very important to proceed for further circuit analysis. That's all for today. Thank you very much.